So what is it we gotta do for now? Let's see. It's exercise 5.20. Okay, and as you can see, I've already created a class. Let's go through it. So here is it right here. Let me zoom in a little bit. Let me scroll to the right. Oh, it seems like we're good. So we gotta display prime numbers between 1 and 1,000. You know, I'm kind of against the ideology of referring to some solution that is already given to us. So what I'll simply do, I'll simply give out my own. Okay, so here's what we're going to do. By the way, I'll give out 2 solutions on this problem. Okay, so this is the first one. So here's what I'll do. I'll simply create a variable which will determine whether or not a number is prime, and an integer a variable called count that will count the number of prime numbers that have been displayed so far. And again, we'll use this variable in order to determine whether or not we display a number on a current line or on the next one. Okay, let's see. Of course, we're gonna use a for loop. Again, we're being told that we'll start from 2 up to 1,000. Brr. I don't even know why I said that. Okay. First thing we wanna do, we wanna initiate our is prime variable, and for each and every number, at first we're gonna presume that that number is prime. Okay, and then we'll do the following to determine whether or not our hypothesis was true. It's kinda windy where I'm at, so my papers are getting blown away. Okay, but we'll keep going. There ain't no excuse. That's how a black American would have put this. There ain't no excuse. Okay, so int j equals to 2. We're starting from 2 up to I. Again, remember folks, I is a number that we actually trying to tell whether or not it's prime. Okay, of course we don't want to include it, so we increment our j. Okay, so here's the deal. We'll simply check if I is divisible by j, and if that's indeed the case, immediately we know that number is not a prime number. So we'll update our is prime number, we'll make it false, and then we'll break our loop, our inner loop. That is to say, we go to the next number to determine. Okay, however, before we go to that next number, we'll check the one we're currently working on, whether it's prime. So if is prime, this is the part where we go to display. Or firstly, I'll increment my number, my count, which simply counts the number of prime numbers. Okay, so far, so it's gonna be system.out. Oh, there we go again with this machine. Can be slow sometimes. Okay, so it's gonna be system.out.print. system.out.print. I want to print I, and then once I do so, okay, so here's it. Here's what I'll do. I want to avoid writing a bunch of if else statements, so what I want to do is to simply go if count mode 8. Remember, we were told that we want 8 prime numbers per line. If this gives us a 0, what we'll do, we'll simply go to the next line. Of course, we'll go to the next line, otherwise we'll stay on the current line. Okay. That should be pretty much it for this solution, you guys. Let me hit the run button and see if I didn't make any silly mistakes. I'm not sure, you can verify yourself, you guys, but these are the prime numbers that one would get, starting from 2 up to 1,000. Okay, that was number 1. That was the first solution. However, there's something I want to point out here. You see, the solution is kind of inefficient in a way that when it comes to this inner loop here, we don't want to go all the way, starting from 2 all the way up to a number, up to I itself, excluding I, of course. We can make our solution a bit more efficient by simply going halfway through. Okay, let's see if we do that, what we get. Seems like we get one and the same thing we had before, right? I know this might seem useless, but think of a case where we've got a huge number like this one, right? What we would want to do in that case is to definitely make use of these facts. Take advantage of it. Okay, that should be it, folks. See you on the next solution.